There is a planet nearly 40,000 light years from here that no human being has ever seen and almost certainly never will. We know it is there, we know roughly how heavy it is, and we know how far it circles from its star. Beyond that, almost nothing. The telescope that found it was never built to look that far. Its working range reaches only about 150 light years from Earth. This world sits more than 250 times beyond that boundary, deep toward the crowded heart of our galaxy. And the evidence for it had been sitting quietly in an archive, recorded and stored and completely unnoticed for years. On the 1st of July, 2026, astronomers announced its discovery in the astrophysical journal Letters and gave it a name, Gaia 23 Brabi. The study was led by Mallory Harris, a doctoral candidate at the University of New Mexico, working alongside Professor Diana Dragomir. What they found is a giant, roughly 1.5 times the mass of Jupiter, the largest planet in our own solar system. It circles an orange dwarf star, a sun smaller and cooler than our own, carrying roughly 80% of its mass. And it keeps its distance, orbiting about as far from that star as Jupiter orbits from the sun, out in the cold and the dark. That distance matters because it is precisely what should have made this planet impossible to find. The telescope in question, NASA's TESS, hunts planets by watching for a shadow. It waits for a world to pass in front of its star. When it does, the starlight dims by a fraction of a percent, and that tiny dip is the signature TESS was designed to catch. But a planet orbiting as far out as Jupiter crosses its star only rarely, and from 40,000 light years away, that shadow vanishes into nothing. So this planet was not found by watching light disappear. It was found by watching light bend. A century ago, Einstein described a universe where mass does not simply sit in space, but bends the shape of space around it. Light traveling through that bent space bends with it, and occasionally the geometry of the sky arranges itself perfectly. When one star drifts almost exactly in front of another, the nearer one becomes an accidental lens, focusing and magnifying the light of the star behind it. For a short while, that distant star appears to brighten dramatically, not because anything changed within it, but because space itself is doing the work. And if that nearer star happens to carry a planet, the planet adds its own small warp to the geometry. It appears as a single sharp spike riding on the shoulder of that smooth curve, a brief, unmistakable interruption. That spike is the entire evidence. There is no photograph, no resolved dot of light, nothing that could be called an image. It is also a method that has revealed less than 5% of all the exoplanets we currently know of. The first sign of this particular alignment came in 2023, caught by the European Space Agency's Gaia Observatory. Its automated alert system noticed a star brightening, flagged the event, and correctly identified it as one star lensing another. But Gaia looked only occasionally, sampling the sky in scattered glances, rather than watching continuously. The planet's signature lasted only a brief moment, and it fell entirely into the gaps between those glances. Gaia never saw it. Gaia has since been retired, its long survey of the sky complete. Its part in this discovery was finished before anyone knew there was a discovery. But something else had been watching that same patch of sky at the same time for entirely unrelated reasons. TESS stares at each region of sky continuously for weeks, gathering measurements far more densely than Gaia ever could. And buried in those dense measurements, recorded years earlier and stored without comment, was the spike. The planet had already been detected. The measurement existed. It simply sat in an archive, waiting for someone to think of looking for it. Which raises a quieter and more unsettling question. TESS holds roughly 8 years of observations, and almost none of them have been searched this way. There may be other worlds already recorded, already measured, sitting unrecognized in data we have held for years. And it is worth pausing on one honest detail. Every image ever published of this planet, including NASA's own, is imagination. Microlensing gives us a mass and an orbital distance and nothing more. No color was measured, no cloud bands observed, no storms ever seen. Soon that will change in scale, if not in kind. NASA's Nancy Grace Roman Space Telescope is built for this method and may find around 1,000 such worlds. This world was not found by building a better telescope, but by returning to old data with a new question. So what else do you think is still sitting in those archives waiting? Share your thoughts below and subscribe for more journeys like this one.